Hello everyone, welcome to NPTEL class. Here is Chemistry Detective to solve your Chemistry class 11th NCERT problem from your unit 2nd, that is structure of atom. This problem is based on concept of photoelectric effect. Hertz was the physicist who observed that when a beam of radiation is allowed to fall on certain surface of certain metals, when a beam of radiation is allowed to strike surface of certain metals like potassium, cesium, rubidium, which are electropositive metals, electrons or same electrons are simultaneously ejected from surface of metal, and these electrons are called photoelectrons. Not only electrons, ejection of electrons occurs, but these electrons also gain some kinetic energy. These electrons have kinetic energy associated with them, and it was later on observed that first it was believed that both the number of photoelectrons emitted and the kinetic energy of photoelectrons will depend on intensity of light. Later on, Einstein explained this photoelectric effect, for which he has been awarded Nobel Prize. He was awarded Nobel Prize, and in fact Einstein used the idea of photoelectric effect, so idea of dual nature of radiation, quantum theory of radiation, which was given by Max Planck, for which Max Planck was also awarded Nobel Prize. Both these, Einstein as well as Max Planck, both were German. Their origin, both were from Germany, but Einstein lived his life in America thereafter, and Planck was also awarded Nobel Prize. He was made director of Berlin University as well, and was awarded Nobel Prize. And now, after explanation of this photoelectric effect was given by Einstein, we now believe that these number of photoelectrons emitted will depend on intensity of radiation. Greater the number of photons which are striking the surface of metal, greater will be the number of photoelectrons emitted. And second, frequency kinetic energy of these photoelectrons depend not on intensity but on frequency of incident radiation. Greater the frequency of incident radiation, greater is the kinetic energy of photoelectrons. And what he said exactly, he said that radiation of minimum frequency, radiation of minimum energy is only able to cause photoelectric effect, that is only able to eject photoelectrons. And if radiation has energy or frequency greater than this threshold energy or threshold frequency, which we call work function, then rest part of energy will be transferred to electrons in form of this kinetic energy. And the idea I will apply here is this photoelectric effect based on this equation: H nu is equal to H nu naught plus 1/2 of mv square. This is radiation. This is energy of radiation which is incident on surface of metal. This is threshold energy which is essential in order to cause photoelectric effect. This is kinetic energy of photoelectrons. And now, given is wavelength of radiation, first I need to calculate this. I need to calculate energy of photon, H nu. I will calculate E, energy of photon. E is equal to H nu. I will write E is equal to hc by lambda. Now I will substitute value of Planck's constant, 6.626 into 10 to the power minus 34 multiplied by 3 into 10 to the power 8, and I will divide it by given wavelength. Given wavelength is 4 into 10 to the power minus 7, and it comes equal to, energy comes equal to 4.9 into 10 to the power minus 19 joules. In joules, energy comes equal to this. But I have to calculate energy of incident photon in terms of electron volt. For this, I have to divide it by, I know 1 joule is, I know 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. So for conversion of this energy from joules into electron volts, I will divide 4.9 into 10 raised to power minus 19 by 1.6 into 10 to the power minus 19, and inner value of energy in electron volts, comes 3 electron volt. This h nu in energy of incident radiation is equal to 3 electron volt. Now I need to calculate kinetic energy. Kinetic energy will be equal to h nu minus h nu naught. Kinetic energy is equal to h nu. This is energy of incident photon in electron volt, 3 electron volt, minus threshold energy is given, work function is given 2.13 electron volt, 2.13, and kinetic energy of photoelectron comes equal to 0.87 electron volts. This is kinetic energy of these photoelectrons. Now from kinetic energy, I need to calculate, using this value of kinetic energy, I will be able to calculate velocity of photoelectron. Using this equation, kinetic energy is equal to 1/2 of mv square. M is mass of electron, v is velocity of electron. V square will be equal to twice kinetic energy divided by m. V square is equal to 2 into kinetic energy 0.87 V square is equal to 2 into kinetic energy. Kinetic energy is 0.87. I will convert it into joules. Then I have to multiply it 1.6 into 10 raised to power minus 19 divided by mass of electron is 9.11 into 10 to the power minus 31. Here I will, on solving this, I will get velocity. On solving this, I will get velocity of photoelectron. Velocity with which photoelectron will be emitted is equal to 5.5 into 10 to the power 5.5 into 10 to the power 5 meter per second. This is the velocity of photoelectron. First, I calculated energy of photon incident on surface of metal in joules. Then I converted this energy of photon incident on surface of metal in electron volt. Then I calculated kinetic energy of ejected electron, which is equal to incident energy which is incident on surface of metal, and threshold energy of this metal, technically named as work function, 3 minus 2.13. Kinetic energy, electron ejected from surface of metal has kinetic energy 0.87 electron volt. From kinetic energy, I needed to determine velocity of this electron ejected from surface of metal, and velocity I got. First I converted energy from electron volts into kilojoules, for which I introduced multiplying factor 1.6 into 10 to the power minus 19. Then I solved the equation for velocity. I got 5.5 into 10 to the power 5 meter per second. And this all was idea of photoelectric effect, that when beam of radiation strikes surface of metal, actually photons are striking surface of metal, and these simultaneously on collision of photons with electrons present on surface of metal, simultaneously without any time lag, electrons are ejected from surface of metal. And for this to happen, this radiation photon should have minimum energy called threshold energy or work function, then only electrons can be ejected from surface of metal. And if incident photons have energy greater than this threshold energy, greater than work function, then excess amount of energy is transferred into these electrons in form of kinetic energy, such that in accordance to law of conservation of energy, total energy of incident photons will be equal to sum of energy required to eject electrons and kinetic energy of these electrons. And remember two important things, that number of photoelectrons emitted will depend on intensity of radiation, number of photons in the radiation. Greater number of photons will be able to expel greater number of electrons, lesser number of photons will be able to expel lesser number of electrons. And kinetic energy of photoelectrons will depend on frequency of radiation. Light of greater frequency will be able to eject greater number of electrons, and light of less frequency will be able to eject less number of if we use light of greater frequency, kinetic energy of photoelectrons will be greater. If we use light of less frequency, kinetic energy of photoelectrons will be less. If on potassium if we will irradiate potassium, which is electropositive metal, surface of potassium by red light, how much intense red light we will use, no ejection of photoelectrons will occur from potassium. But once we turn color from red to yellow, even mild yellow, ejection of photoelectric effect occurs, ejection of photoelectrons occurs from surface of potassium. It indicates that there is a particular energy, there is particular frequency, such that below this frequency photoelectric effect will not occur, above this frequency only photoelectric effect will, above or equal to this, if frequency is equal to this frequency or above this frequency, photoelectric effect will occur. Now there are also two cases. If this frequency is equal to threshold frequency, only photoelectrons will be ejected, they will have no kinetic energy. But if frequency of incident radiation is greater than threshold frequency, then excess frequency will be given to photoelectrons in form of kinetic energy. So I said kinetic energy of photoelectrons will depend only on frequency of radiation, and number of photoelectrons will depend on intensity of radiation, that is number of photons present in this radiation. Thank you. Class 11 students, be blessed. This is what I have got for you in this short session. Take good care of yourself. See you day after tomorrow, as tomorrow is turn of class 12 students. Allah Hafiz.